Hi, my name is Manish Gupta, and in this video, I'm going to talk about the Phi 3.5 model from Microsoft. So what are the Phi 3.5 family of models? This family comprises of three main models, Phi 3.5 Mini, 3.5 Vision, and Phi 3.5 Mixture of Experts, MOE, right? All of them have a vocabulary size of 32,000 and a context length. They take a context length of 128K. So that's a pretty large context length, right? The interesting part is that they are also multilingual in nature. They support these languages: Arabic, Chinese, Czech, Danish, Dutch, English, Finnish, French, German, Hebrew, Hungarian, Italian, Japanese, Korean, Norwegian, Polish, Portuguese, Russian, Spanish, Swedish, Thai, Turkish, and Ukrainian, right? So lots of languages are supported besides English, of course, right? It has a cutoff date of October 2023. So all of these models have a world knowledge of up to October 2023. If you think about Mini Instruct, it's a 3.8 billion parameter model. And in this range, it's probably the best model which is available right now. I mean, these models were launched as latest as basically just like 1.5 months back in time. And they are basically the best models in this range, about 3.8 billion parameter range. Um, However, to pre-train them, of course, it required crazy infra. So 512 H100 80 GB GPU RAM machines for 10 days on 3.4 trillion tokens. The Phi 3.5 mixture of experts model, of course, the model is large because it has 16 different experts with each 3.8 billion in size. But when you care about active parameters at inference time, it's just 6.6 billion parameters where two experts are active for any token at any point of time. Okay. So yes, loading it in RAM is expensive. However, from an inference perspective, it just uses 6.6 billion active parameters for any token. Training it was again difficult. So 512 H100 80 GB GPU RAM machines for 23 days on 4.9 trillion tokens. The models have also been trained for post training has been applied, safety post training on these models for all kinds of purpose. I mean, using SFT, supervised fine tuning, direct preference optimization, and of course, post training has also been applied for helpfulness and harmlessness. Okay. Now, the interesting chart, this chart is super interesting. It sort of shows on x-axis size in billions of parameters, y-axis model quality. Of course, if you have a large number of parameters like Mixtral, 22 billion, 8 experts, 40 billion parameters gives you some quality, about 75. This basically averaged over the MMLU dataset, benchmark datasets, right? However, the Phi 3.5 MOE with just 6.6 billion active parameters basically gives you better accuracy. In fact, 3.5 Mini, is a 3.8 billion parameter model, and no other model in that range is as accurate as 3.5 Mini. Okay, so that's that. So let's basically look at how does Phi 3.5 Mini perform. Now there are several numbers here, and I'm not going to talk about everything, but I'm just going to give you a broad overview of how does it perform, right? So this comparison of Phi 3.5 Mini, remember, it's basically not the vision model or not the mixture of experts, the smallest guy out there. And these are the results across several different categories of benchmark data set. These are not one data set. Like detailed results are in the paper. It's a few tens of data sets touching are almost 100, right? But spread across different categories. And what you observe is across categories, Phi 3.5 does really well. Sometimes it actually even beats the 7 billion Mistral model. In fact, it sort of beats it almost on many such of categories, right? So many categories, it's better than the Mistral 7 billion model. Of course, it is way far away if you compare it with GPT-4o. GPT-4o is way better, clearly, across all of those, but GPT-4o is crazy large as well, right? Phi 3.5 is basically much smaller, but still gives you reasonably good results. I mean, comparable to 7 billion, 12 billion, or other Llama 3.1, 8 billion parameter models. So compared to that, on average, you would observe that this column is actually on average better compared to any of these particular columns, right? GPT-4o clearly is way better. Okay, so there is a lot of room to cover still in that small range. So these are results on the multilingual benchmarks. So even on multilingual benchmarks, you observe that Phi 3.5 Mini is comparable to many other smaller models, but I mean, not surely very comparable with GPT-4o. But if you look at it, 55.2 on average across many multilingual benchmarks is better than 5.3 mini itself, which was which was pre-trained on smaller size data and so on, and much better compared to Mistral, much better compared to, or other, yeah, equivalent in comparison to Mistral Nemo. But if you compare with the Llama 3.1, again, it is 5.3.5 is much better. So you would have observed Meta AI and Microsoft doing this nice game. When Meta AI launched Llama 3, Microsoft also launched 5.3, and then Meta AI came up with Llama 3.1. There is a 5.3.5, which is slightly better compared to 3.1 anyway, right? So there's this interesting game going on. But anyway, it's all good for the scientific community because, well, it gives interesting models for people to experiment with and so on, right? And use it in various applications. They also experimented on long context tasks like summarizing long documents, meeting transcripts, long document question answering, information retrieval. And again, you observe that 5.3.5 compares really well with these models in similar ranges. And in fact, on long context tasks, it actually also compares nicely with GPT-4o in that sense. Okay. Here's an example application where GPT 3.5 Vision performs really well on multi-frame input. So these are different slides which are provided as input, 6 slides provided as input to GPT 3.5 model. And the model was asked to summarize these slides. And look at the interesting summarization. This is not a complete, I think this is a complete summarization. Sort of it says, hey, the slides talk about some introduction and then some domestication of dogs, working dogs, nutrition and exercise and so on. So it's from some kid's textbook. And it nicely summarizes the details in these slides. So 3.5 Vision really does an awesome job at detailed image comparison, multi-image summarization or storytelling, and video summarization. So here is some objective comparison of 5.3.5 Vision with other models. In fact, 5.3.5 actually established state-of-the-art across multiple benchmarks. So MMMU benchmark it raised SOTA to 43, MMBench to 81.9, and text VQA, text visual question answering, to 72. Okay. Here are the results on the Blink benchmark, image-based benchmark across comparison with multiple other models which can also process images. And on average, it's like 57, which you can see is way better compared to all of these guys. But of course, Gemini Pro or GPT-4o, which are like closed models, and that too very large, are somewhat better. Right? There's a comparison on videos as well. So on short videos, long videos, and so on. So specifically, if you look at it, 5.3.5, this is the overall across all sizes of videos. And clearly compared to these similar size models, it performs well. But GPT-4o again is way better, 68.4. GPT-4o is better well across all of those size ranges for the videos, short, medium, and long. But broadly, I mean, compared to smaller models, 5.3.5 does well. Gemini, yeah, I mean, these models are pretty large. All of these models are pretty large on the right side. So they're all closed as well. So if you think about the open model, openly available model, which you can download and fine tune maybe and use it, it's a great model, right? So lastly, let me talk about 3.5 MOE. So MOE is a mixture of experts model, as we discussed earlier. And again, similar benchmarks on which the mini was also evaluated, and similar multilingual benchmarks as well. And if you compare it with, now you compare it with the Mistral Nemo 12 billion, well, that's basically nowhere compared to the MOE, the mixture of experts model. The mixture of experts basically brings it much closer, in fact, better than Gemini 1.5 Flash. Okay. Similarly, for multilingual models, it basically is comparable to Gemini 1.5 Flash. Although even with the mixture of experts kind of a thing, it's not really very close to GPT-4o. But hey, we are closing the gap with the closed models, so which is a great idea. Okay. Okay, so in summary, in this video, I talked about 5.3.5 model. The architecture is just the same. There is not too much of changes in the architecture, decoder only transformer architecture. But there is three members in the family: Mini, Vision, and MOE, mixture of experts. It has a large context length of 128K, which is really suitable for many long context applications. And in case of long context, actually compares favorably with GPT-4o. Right? It's a small model. Mini instruct is just a 3.8 billion parameter model, can very easily fit into your even your 16 GB V100 machines, 16 GB GPU VRAM machines, right? The mixture of experts model has 6.6 active parameters, 6.6 billion active parameters, and in these model ranges, they are the best performing models for text and vision tasks. Okay, that's it for this video. Hope you liked it. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage.